we'll just wait for 5 more minutes. We'll start the session at 4:05. Okay? To see if someone else joins. So maybe we can start with a brief introduction of all of you. Prakyat, just say about yourself. Okay. Lindsay, Matthew. Okay. Yeah. So Uday Kumar. Okay. Okay. Yeah. Parthasarathi. Okay. Welcome. Vignesh. Vignesh. You can unmute and speak. Are you able to hear me, Vignesh? Okay. And who else? Others, can you just introduce yourself one by one? Nice. Okay. Amritavarshini. Okay. Okay. Vidyashankar. Okay. Who else are there? Himon. Okay. Okay. Deepan. Deepan, you're able to hear me? Okay. Chetan Rati. Okay. Anyone else who I've missed? Please introduce yourself. Hello, Nirmal. Okay. Okay. Welcome. Okay. I welcome you all. I'm Kritika. I'm a research scholar at IIT Madras. My major area of research is in polymers, in which I work on natural polymers, especially on mucilage. This is again from plants, especially from seed mucilage. I think hope you would have all seen or eaten Faluda. Someone can answer. Yeah, you would have seen that black seed with a jelly like surrounding. Yeah, I work on that. Okay. Okay. So that is a brief introduction of myself. So I welcome you all for this live interactive session. And I just want to say that this is going to be very interactive session. It's not that I'm just going to speak or I'm just going to explain. It's it's going to be a mutual interaction so that we all learn better. So please don't hesitate to answer. So whether it is right or wrong, it is more on attempting something. Okay. Over the process, you'll be learning. Okay. Fine. Okay, fine. So have you all gone through the lectures? Okay, all of you have gone through the lectures. Is it? All of you have gone through? Okay, okay, that's nice. That's nice. So, you will have, or you all would have got some idea, right? On the concepts, in the lectures, right? Okay, yeah, okay. So this interactive session, as I said, it is going to be interactive. So both of us are going to speak, myself and all of you. Okay, it is going to be interactive. And the flow of the session will be, first I'll give you a brief recap of the lecture modules. Okay, whatever was, taken up in the week. Okay, and this will be followed by solving of some problems. This will be both conceptual as well as numerical problems. And we'll also be solving some gate problems as well. Okay, and the session will also include doubt clearing sessions. Okay, doubt clearing. Okay, whatever doubts you have, you can just ask during the session. Okay, please feel free to ask. Also, I request you to post your doubts in forum. Okay, so that we all will, myself and the professor will be able to view it, and we'll be able to answer it well in advance. Okay, as and when you ask the question also in the forum itself, we'll be able to answer, or as a collective one, where I'll be discussing during our live interactive session. Also during the live interactive session, I just request you to answer, ask any doubts you have. Okay. Okay. Is it fine? Yeah, all of you are clear with the flow? Okay, fine. Yeah. So please feel free to answer. Okay. Don't hold yourself. If you are not able to unmute, you have some problem with your mic, you can just type it in the chat box also. Okay. Is that fine? Good. Great. Okay. Let's go into the session. Okay. So, welcome Shweta. Shweta, you're able to hear me? Okay. Just give a brief intro of yourself. Okay. Okay. Oh, fine. That's nice. All the best. Okay. Now let's get on to the course. Okay. One second. Let me share my screen. So you are able to see my screen, right? Okay, fine. So I welcome you all for the live interactive session for the course Polymers, Concepts, Properties, Uses and Sustainability. This course, is taken up by Professor Abhijit Deshpande of IIT Madras, and this live session is taken up by myself, Kritika. I am a PMRF research scholar at IIT Madras. Okay. So let's go on to the week 1 sessions. Okay. So we'll have a brief recap. Okay. Now it's more you're going to say. Fine. So what are the things you saw in lecture 1? So lecture 1, it started with why are polymers so common, right? Hello, someone can answer please. Okay, I need different people to answer each and every question, not the same person. That is also one more request so that everybody gets a chance and you're able to interact. Okay, please don't shy at all. You can just say whatever you think based on the course content. Okay, whatever you remember. There is nothing right and wrong. End of the day, you will be learning all the concepts. Okay. Okay. So what were the things we learnt in the lecture 1? Can someone say start or should I start? Okay, let me start. Yes. Advantages and disadvantages of polymers. And what were the advantages you saw? Okay. Okay. What is it? Can you repeat? Okay. Yes. Yes. Nice. So you saw the mechanical responses, ease of fabrication, the cost and durability. Okay, the different aspects of advantages. And then disadvantages. In disadvantages, what are the disadvantages you saw? Okay. Okay. Performance in what sense? Can you cite an example? Okay. 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 So what are the disadvantages in the sense? The standard properties. Okay, standardized properties. One polymer doesn't have a single property. It depends on lot of factors like your chain length, okay, your molecular weight. If molecular weight changes, there will be minor changes in the property as well. Okay, you saw the physical aging and thermostability as someone of you said, and then performance. So performance, you might not get a modulus as similar as a steel, right? And then again, one big aspect what all of us are talking about is sustainability, right? We all talk about this base generation and renewability issue of plastics, right? Are you all there? Yeah. And then we also spoke, we also had a brief intro on advanced application. So what were the advanced application you saw? Something you remember? Someone can say. Okay, that's nice. Yes. Okay. Okay. Yes. Yes. So it has, numerous applications, right? Okay. And then there was an introduction to the course module where the module was set as its concepts, properties, uses and sustainability, right? Okay. Now, what was on the lecture 2? So lecture 2 was what are polymers and its unique feature, right? And it was on the course module concept, especially on structures, right? So what were the things you saw? Can you repeat? Uh, I think you have some echo, I guess. Can you someone repeat it? Okay. 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 Nice. Okay. So we saw, first of all, the first description of modules. Like concept will cover why and how, properties will cover the measurements, the quantification, like how much, uses, where it is used, and sustainability. So finally, what we are going to do with this, polymer waste, or how are we going to recycle, right? And then how to describe polymers. So polymers are basically macromolecules, right? They are giant molecules, correct? So there was introduction to monomers, oligomers, and diversity of polymers around us. You all know, right? Even our body is made up of numerous type of polymers, correct? Yeah. Can someone say some polymer in body? Yes. 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 Amino acids are building blocks, so they are the monomeric units actually. Okay. Okay, that's nice. Then functionality. Okay. And then molecular architecture was discussed. So there was discussion on backbone, okay, carbon backbone, and then your side groups, and then your end groups, degree of polymerization, branching. Can someone say what is degree of polymerization? Yes, 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 that's nice. Okay, okay. Then lecture 3 was on, again, on what are polymers and its unique features. It was on concept, process, structure, and property, right? So what are the things you learnt in that? What is it? Yes, yes, yes. Liquid like, solid like. Okay. What else? Some, yes, 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 yes. So we had on. I think. Can you all mute yourself? There is a lot of echo. Just answer and then mute yourself again. Okay, to avoid echo issues. Okay. So there was discussion on processing. So it started with different polymeric materials like polymer, copolymer, blend, composite. So what is a composite? Can you just say some example of composite? Yes, yes, yes. So polymer composites will have some fillers. Okay, polymer as a matrix and some fillers. Okay, and then porous polymers, polymer charge complex. And then on processing, you saw on melt processing, shaping, curing, solution processing, dispersion, machining, joining, mixing, etc. Right? And then structure and properties was introduced. So where, as you said, the states of interest, liquid like and their associated properties, solid like and their associated properties were discussed. Okay, and this was followed by identifying the relationship between processing structure, processing property, structure property, right? And then fourth lecture was on biopolymers, correct? So we had, first of all, the basic classification of polymers. First based on monomers, then on common families. Can you cite some examples on common families? Okay. And then what else? Yes. 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 Okay, that's nice. Then natural polymers were introduced, right? Correct. Synthetic and natural polymers. So natural polymers were introduced. And then some more related terms like bio-based polymers, where the raw materials are from natural resources. And then on natural fibers like polylactates, polyols, and then biocompatible polymers. So biocompatible polymers, should it necessarily be a natural polymer? Someone can answer. So it need not be, right? But what should it comply with? It need not be, necessarily natural polymer, correct? It can be a synthetic polymer as well. But what should it, comply with so that it is biocompatible? And where is it used? Yes, in health application. So if you want to use it in health application, obviously it should be compatible with a human body, correct? Okay. And then you were introduced on biodegradable polymers. Next, type of biomacromolecules based on type. So can you just say based on type what were the molecules? How are it classified? Someone can say based on type. Proteins, yes. And then polysaccharides, polynucleotides, right? And then again based on origin. So based on origin again from plants, animals and microorganisms, right? So can anyone say any example of polymer from microorganism origin? Okay, okay, okay. That's nice. That's nice. One was, it was bio-based polymer, right? From natural sources. Again from fermentation, again xanthan and gum as well. Okay. And something from animal origin? Huh? Gelatin, yes. Gelatin, collagen. Okay, these are all animal origin. Okay. And then what are polymers and its unique feature? Then we came into the property. What is molecular weight? Correct. So in molecular weight, there was a discussion on effect of molecular size. So how does the length, branches, blocks, like if you have a copolymer, how are the blocks? Whether it is like 3 blocks of A and 3 blocks of B, or it is 5 blocks of A and 5 blocks of B, or it is like AB. So how does it really impact your molecular size? And right, those are different kinds of copolymers, right? You have some kind of sequencing, some kind of blocks, length of each block, like A block can be only 3 units, B block can be 5 units, okay, in a particular polymer chain. In other case, A block can be 5, B can be 3, or sometimes both can be equal. So each will have a different molecular size, correct? And then cross links, the number of cross links, right? All these affects, your molecular size and indeed your molecular weight, correct? And then mono on polydisposity. So as synthetic polymers, when they are synthesized, in many cases you will not get a single molecular weight, correct? Someone can answer. So for example, in case of a polyethylene, you will have polyethylene of different chain length and different monomeric units in each. So that is why we go in for averaging, right? Are you all there? Yes. Okay. So then we got into the concept of molecular weight distribution, where we had discussion on discrete and continuous, right? Then molar mass definition, where we had number average, weight average, viscosity average, and Z average. And then dispersity and polydisposity coefficient, right? Correct? Someone can say, yeah. Okay. Then lecture 6 was on concept polymerization, right? So it was again on molecular structure control. So the ultimate aim of polymerization is to control the molecular structure. So as we already know that each chain might be of different chain length and number of monomeric units and all, and it will have different acticity, chirality and all, right? And then in architecture as well, there will be different sequence, as I said, like in copolymers. If you have two polymers, you will have alternating A and B, and then even in that, it can be either A B like that in particular chain, or A B B, or A B B, correct? So that sequence will be changing. And then again branching, the number of branches, the length of branches, networking, and other different architectures. You had like dendrimers and all, right? Dendrimers, star-like polymers, correct? And then how do you quantitatively control it? So based on your average molar mass or molecular weight distribution, average segment length, and segment length distribution, it is actually SLD, not SWD, branching density and length of the branch, and then number of star branches and all. So these measures will help in quantitatively controlling, correct? Are you all there? Yeah, I need someone to answer if you are all there, so that I know that I'm connected, because when I'm presenting, I may not be able to see you people, right? And then there was a discussion on step polymerization. So polymerization of which material, which polymer was discussed in that? Someone remembers? Okay, but okay, that's nice. So uh, what is the other name of this polymerization? Hmm? It is condensation polymerization. So for example, in case of polyethylene terephthalate, two molecules, they condense, right? And then they form, and there will be a loss of a small molecule like water. In case of PET, there is a loss of small molecule like water, but this step polymerization will also happen without any loss of small molecules, like in case of polyurethanes. Okay. And then we had a discussion on polymerization of olefins, where you need a active center, correct? Like a free radical, correct? Yes, yes. And the final lecture of the week was on sustainability, right? So the nature of bonding was discussed, and structure at multiple scales, both time and length scales, right, was discussed. So there will be a time scale variation as well as length scale variation, right? So can you just cite some example? What are the scales? Someone remembers? What are the scales we had? That was discussed. Someone remembers? Someone okay, so it was starting from your atomic or electronic, orbital description, to you have your bond, like covalent bonding, and then your segments, and finally your bulk scale. So in each different scales, there will be different, time scale of behavior also, right? Just hold on for a moment. I 1 second. Sorry for the interruption. Okay, and then we had from how do we bring the macromolecules to small scales like depolymerization? So bringing into concept of sustainability like depolymerization, decross-linking. Correct? Are you all there? Okay, okay. And then how degradation of macromolecules like the scission of backbone or branches, cross-links, and then activation of degradation like thermal, photolysis, catalytic, enzymatic, oxidation, hydrolysis, radiolysis. Okay, and then what are the questions related to sustainability? So what is the life cycle cost, and then degradation in a holistic manner. Correct, and then polymers as a part of biogeochemical cycles. So whether we can bring the synthetic polymers also into a biogeochemical cycle, right? These things were discussed, right? And in case of degradation in holistic manner, so the polymer shouldn't degrade during its service time, and it should not have some degradation during its recycle period also. And after all these things, it should be a it should be degradable. When we are, when you come to a stage where you cannot use it anymore, then it comes to a degradation stage. There only it should degrade. Okay, that is what degradation in holistic manner. Correct? Right? You're all there? Okay. And then we'll go to the practice assignment session. Okay. Let's get on to the first question. So match the polymers to their families. So we have 5 different polymers and 5 different families. Now just match it. So just say one by one. To which family does it belong? Polyurethane? Is it? All of you agree with that? That's right. So it has this NHC double bond O linking. Okay. C double bond O O. Okay, it should have NH C double bond O O. Right, in the linking, polyurethane. And then polyamide. Huh? Yes. Sorry. I already told the, okay. You're right. So it will have C double bond O NH. Right, it is a polymer, of combination of an acid and a amide. Right. So C double bond O NH. So polyamide. 5 is right. Polyether. I think you would have seen the answer. Yes, it has this O group connectivity, right, between the monomeric units. And then again, sorry. Polycarbonate is? Yes. And of course, polyester is 4, right? Right? Yeah, fine. Okay. Now, let's get on to the question number 2. So, polyethylene varieties have densities in the following order. So, HDPE has the highest density, followed by LLDPE, LDPE and VLDPE. The differences in densities are due to the ability of chain segments to pack themselves next to each other. From the figure, choose the correct representation of branching for the variety of polyethylene. So, you have to choose, which one of the, representation matches with each. So do you know what are the abbreviation of HDPE, LLDPE and all? Can someone say? Okay. Oh, okay. 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 Fine. Yeah. That's nice. So now say which one matches with each. The first representation matches with what? Is it 2? Are you sure? Is it low branching? Is it? Which one? Fourth one is what? Is it? Just look into it. How do you say second one is HDPE? Yes. Yes, you are right. Second one is HDPE. Okay. So then, which is LDPE? Is it 4? Okay. Is it so? Is it so? Think for a while and answer. Someone else can answer as well. Is it number 4 LDPE? You have to say why you're saying also. You have to justify your answer also. Okay? Okay. 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 So what are the other two? Someone wants to try or shall I say the answers? Number 3 will be LLDPE. Okay, why you're saying? Okay. 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 Don't bring in crystallinity and all. Just okay. Let's go on. Let's wait for others to answer as well. Someone else want to try? Okay, I'm just going in for the answer. Shall I? I'm going. Okay, this is the answer. I'll say why. Okay. So HDPE, as you said, high density, that means very less branching. So very less branching means, you can have more number of polymers near to each other. So you can have a high density, right? More better packing, correct? And LDPE is one because you have more branching in that case. And when you compare LDPE and very low density polyethylene, you see that there are much more branches, correct, compared to LDPE. So obviously your packing density will decrease. That is why you have it is very low density. And then LLDPE, it is a linear, it's more linear, but it does have branching. Fine. Are you all clear? Clear, Paka? And this density and this packing arrangement, it really plays a very vital role in application point of view. For example, your LDPE, you get a normal, polythene bags, right? Which is of very low quality. Whereas when you go for HDPE, you can go for some bags like your milk bags, right? The density, the small variation, the variation in density, it really changes an application, right? Okay, now let's go on to the third question. So this is a GATE question asked in 2020 GATE. So which of the following statement is incorrect? Nylon 6,6 is produced by condensation polymerization. Phenol formaldehyde resin is a thermosetting polymer. High density polyethylene is produced by condensation polymerization. And polyethylene terephthalate is a polyester. Which of these is incorrect? Why do you say it is incorrect? I wanted justification also. Yes, so yes, you are right. So it is based on this addition polymerization where you form the active centers based on the free radical, right? So HDPE is produced by chain or addition polymerization and it is not produced by condensation polymerization, right? So you activate the monomer and with the active center you start polymerizing it, right? And why are the other statements true? That also we should see, right? Correct. Someone can answer. Hello, are you all there? Shweta, are you there? Yeah. So how do you say nylon 6,6 is produced by condensation polymerization? You already have the answer in the screen also. You can just read through and say. Okay. So it is formed, the monomers are an acid and a amine. Okay. So these come under this polyamides. So you would have this C double bond O NH, bonds between the two different monomers, and this is formed by a loss of water molecule. So the the functional groups COOH and NH2, they react and there is a loss of water molecule, correct? And that is why it is called as condensation polymerization, right? Yeah. Okay. And then what about polyethylene terephthalate? It is a polyester, right? You have the C double bond O bond, C double COO linkage, correct? Yeah. Ethylene glycol and terephthalic acid reacts to form polyethylene terephthalate, correct? Okay. And then next is phenol formaldehyde is a thermosetting resin. How do you say that? You have the answer here. Someone can at least see and say. Yes. What happens is that this CH2, it starts forming kind of a networking. Okay. So you can see that there are network groups here. Here you can see CH2, here you can see CH2, right? So there is a complete networking. So there is a cross linking, correct, between polymeric units, and that is why it is a thermoset polymer. Okay. Can someone say some other example of a thermoset polymer? Or okay. Let me ask you another question. So is can we make rubber to thermoset? Or can we cross-link rubber? Are we cross-linking rubber? How? By which process? Yes, yes, vulcanization by addition of sulfur. Correct. Okay. Now, let's go on to question 4. This is again asked in GATE 2007. Okay, match the following synthetic fibers of group 1 to group 2. So, what family they belong to? So you can answer. So, rayon, the synthetic fiber, the rayon is okay. And then Orlon, 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 what is it? Okay. What about Dacron? Okay. You are all right. Perfect answer for all. So rayon is a cellulose. It is actually a semi-synthetic fiber. Okay, it's not completely synthetic because it is from regenerated cellulose. Cellulose again is a natural origin, right? And Orlon, it is again a acrylic polymer. It is a polymer of acrylonitrile. And then Dacron, it is a polyester. It is a trade name of polyethylene terephthalate. Okay, that's nice. Good. Okay. Now identify the type of tacticity in the below figure. Can someone say what polymer is it? Question number 1, what polymer is it? Or all the three same polymer or different? Or all the three same polymer or different polymers? Yes, yes, perfect. Okay. Now tell me what are the tacticity in each case. Okay, why do you say so? Ordered arrangement of what? Uh, okay. So how is it arranged? Okay. What about B and C? Okay, alternate. Okay. So what is B? Okay. Oh, yes, perfect. Okay, that's right. So A is isotactic. So all you can see all these benzene rings are all in one side. So it is isotactic. And then B is syndiotactic. You can see the alternate arrangement of similar groups. And then C is atactic. Perfect answer. So who said that? Okay, that's nice. Okay. Now, okay. Pectin is an example of, is it an example of polyolefin or polysaccharide, polyimide or polynucleotides? What is it? Polyimide? Is it? Is it so? Is it polysaccharide? Oh, so some of you are saying polyimide, some of you are saying polysaccharide. Which is the final answer that I should take? Polysaccharide. Is it? Yes, it is a polysaccharide. Do you know where is pectin present? Huh? Starch. Is it present in starch? Okay. Okay. So what origin is it of? Is it of animal origin or plant origin or microbial origin? Yes, yes, it is a plant origin. Okay. It is a very interesting polymer. Uh, so it is present, in commercial applications also it is used, right? Do you know in where it is used? In commercial applications? I think almost every one of you would have eaten that. I've also told eaten that. Yes, your jams, jellies. Okay. So this pectin, it is made up of, majorly it is made up of your galactronic acid. Okay. It is an acid of your galactose. You know, right? Pentosis, hexosis. Right? It is a hexose. I know. It is an acid form of a hexose called galactose. So you form galactronic acid. Okay. It is again a very interesting polymer. Sorry. Okay. It is, commercially it is used in your jams, jellies. Okay. It is present in fruits. Okay. It is present in your, matrix of your cell wall. Okay. Very, very interesting polymer to work on. You can just go through, in net on pectin. You will find very interesting information. What kind of role it plays in ripening of fruit, right? Okay. Next. This question, how many of you saw this question and solved this question from the lecture? The polydisposity index of a polymer sample containing 200 molecules, each of molecular weight 10,000 gram per mole, 300 molecules each of molecular weight 30,000 gram per mole, and 500 molecules each of molecular weight 50,000 gram per mole is, what is the polydisposity index? This is from the lecture. Someone tried to solve it, and it was a gate question from, yes, good. Someone, you just say it from the lecture or you tried solving it? Someone answered it, no? Who answered it? You solved it, Shivakumar. Okay. How did you solve it? How did you solve it? Okay. What formula? What was the formula given? Is it possible for you to unmute and speak, Shivakumar? Mic problem. Okay. That's okay. Okay. Anyway, you have solved it. What about others? Did anyone else try solving it? I need someone to say if you have solved it or not. Someone attempted solving it. Any replies? You can say yes or no. It doesn't matter. Just a curiosity. Someone tried to solve it or not. It is again a gate question. No. Okay, fine. Now let's solve the same problem here now. We'll solve it step by step. Fine. So first of all, what we are going to find? Someone can say that at least. What is asked? Polydisposity index, correct? So how do you calculate the polydisposity index? Someone can answer. What is it? Can you repeat? Okay. So what is MW? What is MN? What is MW and what is MN? Yes. Okay. So what is the formula of D? It is the ratio of weight average molecular weight to number average molecular weight. Next, what are the information given in the question. Can someone say what does 200 molecules, 300 molecules, 500 molecules denote? Does it denote the total number of molecules present of each polymer chain, or does it represent the number of monomeric units? What does it represent? You can say number of molecules. Okay, you are right. And the next, what information is given? What is the next information? Molecular weight. Yes, correct. So we have information on number of molecules in each case, having particular molecular weight, right? One case it is 200 and the molecular weight is 10,000. The other case is 300, 30,000 is the molecular weight. And third case is the 500 molecules and 50,000 is their molecular weight, right? Now, how do you calculate number average molecular weight and weight average molecular weight? Someone can answer? Any of you remember? You can also put it in chat box. Or you can say there is nothing right and wrong. Anyway, if you are saying it wrong also, I will give you the, what is the right answer as well. I will explain you each and every step. Are you there? Yes. Okay, correct, perfect. Yes, perfect. So those are the formula. Now, the next is to substitute these values. Correct? So it's actually square, okay? It's not 10,002, it's actually square. Sorry for that. Okay? And then your number average molecular weight. You get your weight average molecular weight as 42,777 and your number average as 36,000. Correct? And the dispersity index, you just divide the weight average by number average, you get the answer as 1.19. Correct? Are you all clear how to solve this? That's nice. Anyone else? Any doubt? Any other doubts? Okay. Now, let's go on to the last question. So, match group 1 with 2 and 3. So, in group 1, you have glass transition, stretching the film in perpendicular direction, univiscosity, electrical conductivity. So, match that with group 2, which is having BOPP, crystalline and amorphous domain in P.PSS, segmental mobility, molding of rubber. And group 3, structure determines property, property determines structure, property determines property, property determines process. So, which of these matches? This is actually exactly taken from the course content. So, someone can start. So, glass transition, what does it match with? Okay. And what does it say? Which one? Is it? Is it? You have to justify that. What is it? Property determines? It is property determines structure. Okay. So glass transition, it determines, as you said, it determines the segmental mobility. So when your material is below its glass transition temperature, your segmental mobility will be less. But as it crosses the glass transition temperature, it will be more flexible. The segmental mobility will be more. Okay. And this property determines the structure. So how flexible, how the segments are mobile, right? Obviously, this is on the structure. Correct? Okay. Now, stretching the film in perpendicular direction. What does that matches with? Correct. So, the stretching the film in perpendicular direction in case of no BOPP, you get a particular orientation based on the stretching. Correct? And that process determine a particular, the property of the material. Now, what is the orientation? And based on that, based on what type of stretching you have, there is a change in the orientation, and that orientation indeed affects the property. Correct? Okay. What about Mooney viscosity? Or electrical conductivity? Whichever one you say, the other one will obviously you'll get it. Okay. So what is it from group 3? Is it process determining property? Yes, it is property determining the process. Okay, how easily you can mold it based on the viscosity. Correct? And finally, you have the electrical conductivity. So depending on the crystalline and amorphous domain, okay, your electrical conductivity will change, right? So the structure here, your crystalline and amorphous domain is nothing but your structural, information. So that determines your property of electrical conductivity. Fine. Fine. Are you all there? Okay. Is it fine? So any doubts you have in any of these problems that we discussed now, or in your assignment problems, or in the course, like lecture content, any doubts? Any doubts? Please make this platform to clarify your doubts. Make the best use of it. If you have any doubts, anyone having any doubts? Someone can reply. Are you all there? You don't have any doubt. Okay, normal. Fine. What about others? You're clear on all concepts that was discussed? Someone else can reply as well. You have any doubt? Or okay. Okay, fine. So then that's it for the day. So any doubts you have, please put forth in the forum so that we see your questions, and in the beginning of the next session itself we'll clarify your doubts, or even in the session you can ask your doubts. Okay, so make the best use of this forum. Okay. And try to be more interactive. There is nothing right and wrong. You can answer. If you're wrong, I'll correct you. Fine. Is it fine? Okay. So make the best use of it. Okay, try to be interactive. And also please go through the lecture before coming to this. Okay, so that you are clear with the concepts. You are also able to, you'll answer better with better confidence. I think most of you had gone through the, all the lectures, correct? So maintain that. Okay, fine. Fine. Okay, fine. Thank you all. So have a great Sunday. Okay, all the best. Let's meet next week. Okay, hoping you all will join next week as well. And hope you all enjoyed the session as well, right? So any comments, any feedback? You want something to be added? Anyone please say something. You want something to be added? Okay, fine. Someone has answered. Nice session. Fine. Okay. Okay. So hoping that you all will